Hello students, this is Saima Khan. I am taking topic shift register. Now, this topic belongs to unit 3 of digital system of code CS304. First of all, we will define what is shift register. We all know that flip-flop is a 1-bit memory cell which can be used for storing the digital data. To increase the storage capacity in terms of number of bits, we have to use group of flip-flops. Such a group of flip-flop is known as a register. The n-bit register will consist of n number of flip-flops and it is capable of storing n-bit word. The binary data in a register can be moved within the register from one flip-flop to another. The register that allows such data transfer are called as shift register. Mainly, there are four modes of operation of a shift register, or simply I can say that we can divide shift register into the four modes. The very first is serial in serial out, SISO shift register, serial in parallel out, SIPO shift register, parallel in serial out, PISO shift register, parallel in parallel out, PIPO shift register. So here is the block diagram of the serial in serial out type of shift register. Uh, if we want to design 4-bit serial in serial out register will require 4 flip-flops. Similarly, if I want to design 3-bit shift register of any type, I can require 3 flip-flops. In the block diagram we are able to see there are 4 flip-flops: flip-flop 0, flip-flop 1, flip-flop 2, flip-flop 3, and their output are marked as Q0, Q1, Q2, Q3. Let all the flip-flops be initially in the reset condition, that is Q3 equal to Q2 equal to Q1 equal to Q0 equal to 0. If an entry of a 4-bit binary number 111 is made into the register, this number should be applied to D in, that is data in. The very first point from the left hand side. This D in data bit is termed as LSB. The D input of FF3, that is D3, is connected to serial data input D in. Output of FF3, that is Q3, is connected to the input of the next flip-flop. Likewise, every flip-flop is connected in the same way. Output of the one flip-flop is connected to the input of the next flip-flop. So in the diagram we are able to see that we can serially in the data with the terminal DIN, and from the output we'll get the serial output. Hence there is the truth table which is showing how data is serially transmitted from D into last output Q0. This is the waveform showing the clock, the bit stored in D in, Q3, Q2, Q1, Q0. Now the next type of the shift register is serial in parallel out, that is SIPO. In such type of operation, the data is entered serially and taken out in parallel fashion. Data is loaded bit by bit. The outputs are disabled as long as the data is loading. As soon as the data loading gets completed, all the flip-flop contain their required data. The outputs are enabled so that all the loaded data is made available over all the output lines at the same time. Four clock cycles are required to load 4-bit data. Hence, the speed of the operation of SIPO PO mode is same as that of the SISO. This is the block diagram showing a 4-bit serial in parallel out register which is designed with the help of the 4 flip-flops. We are able to see that data is getting in serially and getting out parallelly with the output Q0, Q1, Q2, Q3. Now the next type of the shift register is serial in parallel out. Data bits are entered in parallel fashion. The circuit shown below is a 4-bit parallel input serial output register. Output of previous flip-flop is connected to the input of the next one via combinational circuit. The binary input words B0, B1, B2, B3 is applied through the same combinational circuit. There are two modes in which these circuits can work, namely shift mode or load mode. Now this is the block diagram showing how data is getting in parallelly with the bits B0, B1, B2 and B3 and getting out one by one with the terminal output Q3. Now the last shift register is parallel in parallel out, which requires no clock pulse to shift all the data. With the help of the enable pin, all the data bits are getting in, and with the same enable pin at the same time the data is getting out. In this mode, the 4-bit binary input B0, B1, B2, B3 is applied to the data input D0, D1, D2, D3 respectively of the 4 flip-flops. As soon as a negative clock edge is applied, the input binary bits will be loaded into the flip-flops simultaneously. The loaded bits will appear simultaneously to the output side. Only clock pulse is essential to load all the data bits. Here is the block diagram of the parallel in parallel out. We The data is getting in with the parallel combination of the circuit, and similarly the data is getting out with the parallel combination of the circuit. Data is getting in with the help of B0, B1, B2, B3 and getting out Q0, Q1, Q2, Q3. In this type of the shift register, no clock pulse is required, only we have to enable our preset pin. This is all for this presentation. Thank you students. Thank you so much.